Holy crap.
There are no known primates here. There's something really out there.
Something really out there. This could be a big...
In one of Expedition Bigfoot's episodes, the team went on yet another potentially groundbreaking mission to find verifiable evidence of Bigfoot's existence. Their target is Bigfoot, also known as Sasquatch, a creature that has captured the imaginations of countless people around the world. Believed to roam the dense forests of North America, Bigfoot has long been a subject of folklore, cryptozoology, and numerous investigative missions. The tantalizing hope of finding a species that is yet undiscovered keeps adventurers and scientists fascinated, even though no definitive proof has ever surfaced. Over the decades, Bigfoot has been synonymous with a mix of hope, skepticism, and fascination. While stories abound, evidence has always remained elusive. Photographs and videos often appear blurry or easily explainable, leaving the phenomenon sitting at the edge of believability. Yet believers persist, and this episode exemplifies why. The footprints discovered during the expedition spark hope that they are finally close to tangible, concrete evidence. Russell Accord, the leader of the team, sees this discovery as a crucial moment, calling it the luckiest day of his life. Alongside Russell is Dr. Mireya Mayor, an esteemed primatologist who brings scientific rigor to the search for Bigfoot, a creature many scientists outright dismiss as a myth. Mireya Mayor, bringing science to cryptozoology. Dr. Mireya Mayor's participation in the expedition elevates its credibility. Cryptozoology, the study of hidden or undiscovered animals, often straddles a fine line between legitimate scientific inquiry and pseudoscience. This is because many cryptids, like Bigfoot, lack clear, verifiable evidence, often leading to skepticism from the mainstream scientific community. However, Mayor's approach is firmly grounded in scientific principles. She brings years of experience studying primates in the most challenging environments, from remote rainforests to high-altitude regions. Her role within Expedition Bigfoot is crucial in ensuring that all evidence is analyzed thoroughly and from a biological perspective. Mayor's willingness to join the team and devote her expertise to the search for Bigfoot speaks volumes about the possibilities cryptozoology holds for science. While some may dismiss the search for Bigfoot as fruitless, Mayor shows that a scientific approach can bring legitimacy to even the most elusive mysteries. She exemplifies how scientific inquiry is not limited by existing knowledge but thrives on the potential for discovery, however far-fetched it may seem. Analyzing the footprints, a detailed study of the evidence. The discovery of the footprints in this episode is a crucial moment for the team. The prints are unlike anything they have encountered before, and the size of the prints immediately suggests that they could have been made by a creature far larger than any known animal in the area. Bigfoot enthusiasts frequently describe the creature as massive, standing anywhere from 7 to 10 feet tall, with a build comparable to a large primate or even a human, but with distinctly non-human features. The footprint's size is striking. They are far larger than any human's footprint, including those left by extremely large individuals such as professional athletes. By comparing these prints to known creatures, the team quickly rules out common animals such as bears. Moreover, the depth of the prints suggests that whatever made them was not only large but also very heavy, another characteristic that aligns with the traditional description of Bigfoot as a massive bipedal creature. The prints also exhibit a notable heel-to-toe movement pattern, which is characteristic of bipedal creatures. This is an essential observation because it rules out the possibility of the prints belonging to four-legged animals. The heel-to-toe motion implies that the creature that left the prints walks upright, much like a human. However, the size and depth of the prints indicate that the creature must be far more massive than any human, leading the team to conclude that it could be Bigfoot. The team takes precise measurements of the footprints, documenting the width, length, depth, and stride between prints. This data allows them to estimate the creature's height and weight, further suggesting that it is a large biped. As the team discusses these details, they become increasingly excited by the possibility that they are closer than ever to discovering real evidence of Bigfoot. Preserving the evidence. The importance of footprint casting. Recognizing the significance of the discovery, The team decides to cast the footprints to preserve them for further analysis. Casting involves filling the footprints with a material that hardens, creating a durable mold that captures the exact shape and details of the prints. This process is crucial for several reasons. First, it allows the team to preserve a physical copy of the prints that can be studied later in a laboratory setting. Second, it ensures that even if the original prints are disturbed or destroyed, there will still be a record of the evidence. The casting process is delicate and requires careful attention to detail. The team knows that any mistakes during casting could result in the loss of critical information. They take great care to ensure that the casts are accurate and capture every detail of the prints, from the heel-to-toe movement pattern to the deep impressions left in the ground. Once the casts are complete, the team feels a sense of accomplishment, knowing that they have preserved the evidence for future study. Footprint casting is an essential technique in both wildlife biology and cryptozoology. It allows researchers to analyze the morphology of footprints in detail, comparing them to known species, and looking for unique characteristics that might indicate a new or undiscovered species. In the case of Bigfoot, the team hopes that by analyzing the casts, they can gather more information about the creature's anatomy and gait, which could help them determine whether these prints truly belong to Bigfoot or another undiscovered animal. Knuckle prints, another piece of the puzzle. In addition to the large footprints, the team discovers what they believe to be knuckle prints. These indentations in the ground resemble the marks left by primates that walk on their knuckles, such as gorillas or chimpanzees. The presence of knuckle prints suggests that the creature responsible for the large footprints may share some characteristics with known primates, possibly using its knuckles for support at certain times. The knuckle prints add a new layer of complexity to the investigation. If the creature is capable of moving on all fours, it could have a gait similar to that of other large primates, such as gorillas. This raises new questions about the creature's locomotion and behavior. Could Bigfoot switch between bipedal and quadrupedal movement, depending on its environment or needs? The team carefully examines the knuckle prints, noting how they are spaced in relation to the footprints. This evidence, combined with the large footprints, paints a picture of a powerful, adaptable creature. The presence of knuckle prints also reinforces the theory that Bigfoot could be a previously undiscovered species of primate. Many cryptozoologists believe that if Bigfoot exists, it may be a relic population of a prehistoric hominid, such as Gigantopithecus, a massive ape species that once lived in Asia. While Gigantopithecus is thought to have gone extinct thousands of years ago, some researchers speculate that a population could have survived in remote areas of North America, evolving into what we now call Bigfoot. The amphibious hypothesis: could Bigfoot live in water? As the team follows the trail of footprints, they make an interesting observation. The prints seem to start near the edge of a body of water. This leads them to theorize that the creature may have emerged from the water before walking through the forest. The idea that Bigfoot could be amphibious is particularly fascinating, as it offers a potential explanation for why the creature has remained so elusive for so long. Most searches for Bigfoot have focused on land-based habitats, but if the creature is equally at home in water, it would be much harder to track. The dense forests and vast bodies of water in many regions of North America provide ample opportunities for a large, intelligent creature to hide. This amphibious hypothesis raises new questions about Bigfoot's behavior and habitat preferences. Does Bigfoot use rivers, lakes, and other bodies of water to travel undetected? Could the creature be capable of swimming or even living partially submerged in water? This theory also opens up new avenues for research. If Bigfoot is an amphibious creature, researchers may need to shift their focus to aquatic environments in addition to the forests, where most searches have taken place. The team begins to explore the possibility that Bigfoot could be using the water as a means of concealment, traveling through rivers and lakes to avoid detection by humans. The discovery of multiple sets of footprints, evidence of a family group. One of the most exciting discoveries the team makes during the expedition is the presence of multiple sets of footprints, some larger than others. This suggests that there may be more than one creature in the area, potentially indicating the existence of a family group or social unit. The presence of smaller footprints raises the possibility that the team has discovered evidence of a juvenile Bigfoot. which could offer valuable new insights into the creature's behavior and life cycle. The discovery of multiple sets of footprints leads the team to speculate about Bigfoot's social structure. Are these creatures solitary, or do they live in family groups? If the smaller footprints belong to a juvenile, what does that tell us about Bigfoot's reproductive habits and parenting behavior? The possibility that Bigfoot may live in social units similar to other primates adds a new dimension to the investigation, as the team begins to consider the implications of this discovery. The presence of a juvenile Bigfoot could also provide clues about the creature's growth and development. By comparing the size and spacing of the footprints, the team may be able to estimate the age and size of the juvenile, as well as the adult creatures. This discovery could offer valuable information about the life cycle of Bigfoot, helping researchers understand how the creature grows, matures, and interacts with its environment.